So we're going to start the new unit, which is surface area and volume. But I want you to understand exactly what surface area and volume is. So generally, what I do for this exercise is when I have the kids in the classroom, I have you go to a Wikipedia page called Platonic Solid, and on the top you can see five the five Platonic solids. And I actually have the kids; they make these. We make these. You can see them. Here's here's the tetrahedron, and here's the octahedron, and here's a cube the kids make. Let's see. This is a dodecahedron. You can see the pentagons, and here is an icosahedron. You can see that, right? The question is, how do they make these? So what the kids do is we use this website. We go to the cube. And the first thing we do is we take a piece of paper. I have some paper in the back of the room. We go to the cube, and let's see, click on cube. And you'll notice on the side, let me move my face out of the way. You'll notice if we scroll down, there's something called a net. And basically, you're going to cut that out of the piece of paper, and then you're going to fold it up. And with a lot of tape, you're going to make this cube. Can we do the other things? Well, let's see, what else? So what other figure is there? Let's go back. We can look at the, what else? The dodecahedron. Also, the idea is you cut out, here's the net. Over here, you can see it on the sides. It's a little elaborate, but you know what? And once again, these are all regular pentagons. So, the artists in the class, they're kind of good at that. And then what you do is you fold it up, and here's the net. You can see how you fold it up, and a lot of tape, you can put it together. And so, once again, so the idea is in class, I'd have you, make the nets. So you can copy these. Let's see, the icosahedron. Let's see what that is. See what that net looks like. So the regular icosahedron, we have the net here. We have the net, and then does it fold it up? No, it doesn't. Oh, there we go. Nice, and then you fold it up. So that's the idea. So the question is, so we have fun this one day. The simple idea is that we use the net, and the paper needed to make the figure, that's the surface area, and the space inside, that's the volume, and that's simply what we're going to be studying. And that's basically it. So you can go to this website. Let's see. You can use the Platonic solids, and then more advanced ones is Aristotelian solids. Let's see, let's go to this website. Archimedean solids. I'm sorry. Let's go to Archimedean solids. And you can get more. These are different nets. And there's a whole page of all these fun little things. The rhombic cube octahedron. And the idea is they give you the net, the snub cube, the icosahedron. Once again, they give you the nets. So it's triangles, and then the idea is you just fold it up, and you can have fun with that. To show no, that's good. Anyway, so you can have fun with this. Once again, it's the Platonic solids and the Archimedean solids, and that's it. Have fun. So we saw in the video the different shapes. So we want to talk about surface area, which was the paper needed to make the object, and when you fold it up, there's space inside. That's volume. So the first thing we want to talk about is something called a polyhedron. Polyhedron. A polyhedron is a 3D figure whose surfaces are polygons. So a cube or a pyramid is a polygon, but a cylinder or a cone is not a polygon. They're still solids, but this first unit, we just want to do solids with polygon faces. So the polygon, each polygon is a face. A face. A face. An edge is where two faces meet. And a vertex is where three or more faces meet. And that makes sense if you think about it. Well, let me go back and get one of the polyhedron. So for example, like here's a cube. So all the squares are faces. Where two of the faces meet, this is an edge, and then where three or more faces meet, that's a vertex. So a cube has only three faces meet, but we saw here, for example, a pyramid, right here, that four faces meet at a vertex. So that's the idea. Once again, good. And so we have something called Euler's formula. Euler's formula, which is that a face plus a vertex is equal to an edge plus 2. And you can see that with some shapes. So for example, let's take a cube. And so let's see, we have, let's see, 6 faces. And we have how many vertexes? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Now how many edges are there? Let's see, 4 edges on the top, 4 along the side, and 4 on the bottom. That means there's 12, and that works out because 14 equals 14. It's kind of cool. I think that's kind of cool, right? Let's go on. Let's try another one. How about a polyhedron with 2 triangles? Actually, we can do, let's choose this one, the square pyramid. So we have the square for the base, and we have, side, 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 side. Here's a square pyramid. We'll be talking about that. Let's see, how many faces are there? So let's see, there's 5 faces. 5 faces? Yeah, 1, 2, 3, 4, 5. Let's see, how many vertices are there? Let's see, 1, 2, 3, 4, 5. 5 vertices. And how many edges are there? Let's see, number of edges. So let's see, 1, 2, 3, 4, and then 1, 2, 3, 4. 8 edges. And that works out because 10 equals 10. So once again, Euler's formula works out for any polyhedron. Now, we talked about in the last class, a cross-section. What's a cross-section? A cross-section is any, because I got this wrong, any intersection of a solid and a plane. Any intersection of a solid and a plane. So once again, my analogy was like the samurai chop. So you take any cube and you chop it like, someone would say, well, chop it down the middle. And then you look at it and go, oh, a square. But you can chop the corner off. Like you can chop the corner off and look and you say, oh, I have a triangle. Is it a triangle? Yeah. So once again, it's any intersection of a plane and a solid. And you take a look at it and you go, oh, that's the cross section. So number 38, let's take a look at the net. So what's a net? You can see in the book, the idea of a net, well, we saw on the net, we saw it on the website. The idea is the paper originally, so remember before we made this, we drew this picture and we cut it out and we folded it up. If we unfold this, that's considered the net. Same thing here, we'd have like a square, and if I undid these, it'd be like triangle, triangle. So like the net for this square pyramid would kind of look something like this. That's the net. Once again, as if you were going to cut it out and make it yourself. We saw the net with the cube. It looks something like this. Kind of looks something like this. And once again, you fold it up. And that's simply the idea of the net. Let's see what else I want to talk about. Okay. So let's move on. Let's talk about surface area. That's it. Let's move on. So surface area of a prism and cylinder. So prism, what is prism? A prism is a polyhedron with two parallel faces called the bases. And then the other faces are also known as lateral faces. Lateral faces. And in a polyhedron, the lateral faces, these are rectangles. And that makes sense. So once again, let's talk about this. Polyhedron. So pick a, I don't know, let's start with a square. And then we'll put a square at the bottom. And the idea is when we connect these lateral faces, so this when we connect these, so these are the four lateral faces. And these are considered, up here, this is the base. Now, a problem is that you might say, well, it's not a problem. It's not a problem. This is known as a right prism, because the bases are directly on top of the other. So the height is basically, this is the height of the prism. So you might say, well, what other cases are there? Well, in your science class, you might see something that looks kind of something like this, like a pipette that kind of is on the diagonal. You might see a figureless, and you might say, hey, Mr. Adler, that's going to be like, well, it's not a prism. The idea is that it's a circle parallel to another circle. And you say, but they're not, it's not directly on top. True. This is called oblique. This is called oblique. We're not studying that in this class. So although they are parallel to each other, it's not right on top. It's oblique. I mean, this would be the height, but we're not talking about. So in this class, don't worry about oblique. We're just, in this class, the two bases are on top of each other, and the height could be considered the distance between the two bases. So the height is the distance between the two bases. Okay, let's continue. So the question is, the first thing is we want to talk about the surface area. So the question is, where are my notes? The question is, like, how much paper do I need to make this thing? What paper do I need? So let's see. So let's define some terms. So first of all, the lateral area is the area of the lateral faces. And so you're like, okay, well, they're rectangles, so that's easy to find the area. And then what's the surface area? The surface area is the area, well, let's call this the lateral LA. It's the lateral area plus the area of the bases. The idea is, imagine, well, I'm talking about prisms, but imagine this is a nice package. You've bought a gift for someone. So you need the sides. The idea is, do you have a bottom? Maybe it's, something, when you go to a museum and you bring home a poster, or you're wrapping up something you bought in a museum, a poster you bought at an art museum, and you have that cylinder. Well, that's the lateral, but the bases are like the top and the bottom, or like a jar or a soup can. So once again, we have the lateral and the sides, and then the surface area, which is the lateral plus the area of the basis. And that's basically it. Let's do an example. Here's a triangle. Here's a triangular prism. And we're told that the bases have a dimension of 5 by 5 by 6, and it has a height of 12. So the question is, what is the surface area? What is the lateral area? And what is the surface area? As you say, fine. The lateral area, let me do this up. The lateral area is the area of the 3 rectangles. And so the first rectangle is 5 by 12. The second rectangle is 5 by 12. And the third rectangle is on the floor. That's kind of like 6 by 12. Well, you're looking at that. If I factor out a 12, I have 5 plus 5 plus 6. But that's equal to the height times the perimeter of the base. Now, what does this equal? Let's see. What does this equal? It's 192. What's going on with the surface area? Well, the surface area is that lateral area plus the 2 times the area of the bases. And so you look at that, and you're like, okay, well, I can easily find the area of a rectangle, but that triangle is weird. You know, it's not right. It doesn't look like it's a right triangle. Well, in this exercise and on the New York State Regents exam, it's going to be easy because if you drop an altitude of an isosceles triangle, you say, oh wait, that's 3, which means due to Pythagoras' theorem, and these work out nicely. This is a 4, so the area of the base. So we have 192 plus 2 times the area of a triangle is 1/2 the base times the height. Final answer, what is it, 204? Yeah, this is 12, 204. And if this is inches, if this is centimeters, then the area is centimeters squared, 204 centimeters squared. Let's try and, okay, let's move on. Cylinder. Cylinder, well, a cylinder is no longer a polyhedron. A cylinder is a solid. It's a 3-dimensional thing whose bases are circles. So we have, once again, we're not doing the obliques. We're only doing right solids. The bases are right on top of the other. So we have a circle and a circle, right? The way I describe it is like pancakes on top of each other. So we have 2 dimensions. There's 2 important things about a cylinder. We have to know about the height, and we need to know the radius. Because once we find if we know the radius, we can find the circumference and the area. So we're good. Now the question is, we want to find the surface area. We want the lateral area and the surface area. Now the question is, if I asked you to take a piece of paper, how would you like cut it out? You know, or let's say you saw like something like this. If you opened it up, what would it look like? Well, we know the tops are circles. But what's going on with the lateral part? Well, that's actually a rectangle. That's actually a rectangle, right? So let's think about this. We know the area this is pi r squared. The question is, what is the area of this rectangle? Think about it. You know, when you have a soup can and you peel the label off and you open it up, it's a rectangle. Well, I know that the h is the height. The question is, what is this length? Well, this was the amount, this was the wrapping it around. That means this is the circumference. This is the circumference. This length is the circumference. So therefore, the lateral area is equal to 2 pi r times the height, which means the surface area is equal to the lateral area plus 2 times 2 areas of the circles. And that's how you find, that's literally like the amount of paper you would need to like make a cylinder. You need to cut out 2 circles, and then you would, you know, have a rectangle whose width, whose base, or one of the dimensions, is the circumference of said circle. Let's move on. What are the next two things we're interested in? And that we noticed with the New York State exam, we're interested in a pyramid and a cone. These are the four things we're interested in. So let's move on. Pyramid and a cone. Let's see. What is a pyramid? Pyramid. Well, a pyramid, it's a polyhedron. The base can be any polygon. The base can be any polygon. In this class, it's going to be in this class on the New York State exam and the IB exam, assume it's a regular polygon. Assume it's a regular polygon. You know, just assume like there's a square base, or you know, what is some other kid? They made a. Do I have? Yeah, this is a tetrahedron. So it's an equilateral triangle base. Once again, assume your base is a regular polygon, and then the faces. So let's think about this. The faces are all isosceles triangles that meet at a common point called the vertex. And you can visually imagine that with our two. Once again, we have here's a square pyramid. The base is a square. The lateral faces are triangle, and they all meet at the vertex. Same thing with your triangular pyramid. The base is a triangle. All the faces are triangles, and they all meet at the vertex. So let's get a picture. Let's get a square pyramid. That's the one commonly used. So we have a square, and we have here's the vertex, and we have the triangular faces. Couple of things. First of all, there's the height of the pyramid. Let's put that we'll put that in red. The height of the pyramid. Sorry. It goes from the vertex right to the center of the square. We know if it was square and we draw in the diagonals, it intersects at the center. And so this is the height. This is the height. The other thing we're interested in to make our life a little easier is something called the slant height. Because we want to know because I'm going to ask you for the lateral area and the lateral surface area, and you're going to have to find the area of these triangles. So often you're going to be given the height. This is called the slant height. It's like the altitude of one of these triangles. So this is known as slant height. And I think the book uses L for the letter. I could be wrong. But once again, this just makes it easier to find the area of these triangles. So I'll tell you what the slant height is. And then the other thing they might talk about is something called the lateral edge. And that's, this is known as the lateral, let's see. And this side where the two triangles meet, that's known as the lateral edge. So you use all your triangle knowledge to see what they give you. You're looking at the triangles. Whoops. So the question is, what is the lateral area and what's the lateral area and what is the surface area? Well, it's 1/2 the base times the height, or the side divided by 4, right? In this case, though, so I used, just for the picture, we know there's 4 of these. So we know it's 4, so let's multiply this by 4. Let's manipulate this a little bit. 1/2 times 4s. Well, 4s is the perimeter. 1 times the perimeter. times the slant height. And that's the lateral area of a pyramid. And then the last part simply is, what is the surface area? Well, it's the lateral area plus the area of the base. So the surface area of a pyramid is equal to the lateral area plus the area of the base. Once again, New York State Regents, IB exams, we're not asking anything more than like a pyramid, and you got all the formulas. In a more advanced textbook, like our textbook, they might give you like a pentagon base, and they might so then you have to eventually find the area of the base. But you don't need to do that. Once again, and you have the formula. Once again, it's the lateral area times the area of the base. And the last thing we're going to look at is a cone. Let's take a look at a cone. What's a cone? A cone is, well, we know what a cone looks like, right? What are some important things we need to know about the cone? Well, we need to know the radius of the base. We need to know the height of the cone. And then the last thing is, we're going to call this last dimension the slant height. So I want you to imagine like you're eating an ice cream cone and like ice cream drips and it drips along the cone. That's the slant height. You should have done this with circles. Let's think about this. How would let's say I had a cone, but there was no top. I just want the lateral area. So the question is, if I took an ice cream cone, like a sugar cone, and I cut along the side and opened it up, what would it look like? And so the idea is, it kind of looks something like this. Now, this is the slant height. This is the slant height, right? That's the green. The question is, what is this, like, this actually is a circumference. This is 2 pi r. And so we actually learned that, well, I think I might have derived it for you, that the area of the sector, because this is a sector, it's actually equal to 1/2 the slant height times like the arc length. You're going to get this information in the formula booklet. Can you see that over there? And so the area of the sector, which is the lateral area, is equal to pi RL. I say pi RL because it reminds me of that TV show on MTV, like TRL. So I'm like pi RL. And therefore, the surface area is simply pi RL plus the area of the base. Now, no one ever puts a cap on the ice cream, but that's the idea, surface area. Next. Last thing. Oh, we did the pyramid. Good. The last thing I want to talk about is volume. Last thing we're going to talk about is volume. Volume is very straightforward. Volume is simply how much stuff we can put inside the object that we created. But let's talk about volume. So we have a cube. We know what a cube is. How am I doing for time? Nice, 11:35. This is a cube, right? And if we call it a unit cube, it's a 1 by 1 by 1. So it's a 1 unit. It's a 1 unit cubed. 1 unit, 1 cubic, or 1 cubic unit. And the idea is volume is the number of cubes you can fit inside something. So volume is the number of unit cubes that fit inside an object. Oh, the air conditioner is not working in this room. I like to make a chart. So what we're going to do is we're going to compare prism, pyramid, cylinder, and cone, because they're connected. They're all connected. So I want you to think of a prism as, two versus a pyramid with the square base, and so with the pyramid, let's think about this. We have our base, and we have our height. And simply put, the volume is, what is the volume? The volume is the area of the base times the height. What's going on with the pyramid? Same idea. We have the area of a base. We have our base, sorry. And we have our height. And the volume is simply, this is kind of cool, 1/3 area of base times the height. That's the connection. That's it. I make it very easy for you. Next, cylinder and cone. What is a cylinder? Well, I say it's like pancakes on top of each other. So we have the base, and we have the height. And what's the volume? What's the volume? Area of base times the height. That's it. What's going on with the cone? Very straightforward. We have a circular base, but this time it goes up to a vertex. Same thing. Let's use the green. We have the base, and we have the height. And what do you think the volume of a cone is? Not a coincidence. 1/3 area of the base times the height. That's it. That's volume. That's volume. Two more things, and then we're done for the entire stuff. The unit that I usually spend 2 weeks on, we got it done in 30 minutes. Let's talk about the sphere. And then there's examples in the book you can figure, or you know what I recommend? Go to the New York State Regents exam, find all the problems, and just do those problems. Next, what's the last thing we're interested in? A sphere. What's a sphere? It's a set of points in 3 space that are equidistant to a fixed point called the center. Now, we know a basketball, a soccer ball, a rubber ball that you play that you hit a handball. This is the idea of a sphere. And so we kind of draw it like this. So the idea is that, this is the sphere. Once again, it's like a basketball, a volleyball. And the main dimension is the radius. Let me put that in red. Let me put that in red for you. So here's a sphere. And every point on the sphere is equidistant. The question is, this is something to investigate, and we don't talk about spherical geometry. It's kind of cool. Just 2 things. We know into the surface area and the volume. I'm not going to derive it. The surface area is, what is the surface area? I think I know what it is. Do I know what it is? Yeah, it is 4 pi r squared. And the volume is 4/3 pi r cubed. So once again, the units are square for surface area, because this is like the paper we need to make this. The volume is the units are in cubes, because this is the amount of unit cubes we can fit inside the object. The last thing we need to talk about is the idea of the ratio of solids. So let's say we're comparing similar solid. Let's use the sphere, by the way. So let's use the sphere. So we have a sphere. Sphere 1 has a radius of 2. And sphere 2 has a radius of 5. So the ratio is 2 to 5. Well, what's the ratio of surface area? Well, this is kind of interesting. The ratio of surface area would be, well, let's figure this out. Let's see what's going on here. So we have, let's see, we have 4 pi 2 squared compared to 4 pi 5 squared. So it's like if we made a fraction, we would see the ratio is 2 over 5 squared. And then the last thing we're interested in is the ratio of what happens to the volumes. How does it affect the volume? And you look at that and you say, okay, the volume of circle 2 is 4/3 pi 2 to the third versus the volume of the radius of 5, 4/3 pi 5 to the third, and we see the ratio of volume is 2 cubed over 5 cubed. So we can come up with some rules. If you come up with some rule, the ratio of solids is A over B. The ratio of surface area is A squared over B squared, and the ratio of volume is A cubed over B cubed. Do I have any problems to work on? No, that's it. And that's the whole unit. So this is the unit. You can work on all the problems in the unit for practice, or you can go to the New York State Regional exams and find all the problems on surface area and volume.